Hello everyone, in this part I am solving questions 13, 14, 15, 16, 18, 21 and 23 in chapter 9. Let's get started without wasting any time. Refer to the following graph. Price of labor is $3 per unit. Wage rate is $3. That's very low. What's the minimum cost of producing 100 units of output? To produce 100 units, you have to be on this isoquant. Okay, the minimum cost of producing 100 units is at point B. You are using 15 units of capital. I don't know how many units of labor. We don't need to do that. We can use this intercept information. This is actually 21. Just to find the total cost of producing this isocost line, the value of this isocost line, right? Because it's this point B is on the isocost line. So if you have any information gaps, please watch my videos. Wage rate is 3. So I can use simply this area to find this intercept to find the total cost, because this intercept 35 is actually equal to total cost divided by wage rate. Wage rate is $3. 3 times 35 is going to be the total cost of production. C, total cost. So this is going to be 105 part B is the correct answer. Question 14. Refer to the following graph. The price of capital is $20. Perfect. Why wouldn't the firm choose to produce 5,000 units with the combination of A? So I'm going to make this a little bit bigger. So I am trying to produce this Q level, 5,000 units of cars or something. The best level of output is actually here. I'm going to call this point X, where this isoquant is tangent to this isocost curve. Okay, perfect. So what's true? What's true at this point X? At point X, I know that slope of positive of the slope of isoquant, right? It's going to be marginal rate of substitution, technical substitution between labor and capital, which is marginal product of labor divided by marginal product of capital. Again, if you have knowledge gaps, please watch my videos. This is the slope of this isoquant at any point. Slope of isocost. So these, I'm going to actually write it with red to synchronize. Okay, to make it consistent. Slope of isocost, those straight lines, it's going to be negative W over R. So this is -2. Okay. So at point X, I know that the slope of isoquant and isocost, are equal to each other. What does it mean? Marginal rate of technical substitution, which is marginal product of labor divided by marginal product of capital, is exactly equal to wage over R. We rearrange them in the video, right? And it became marginal product of capital in the course video. Okay, so then you have this equality. Okay, nice. So at point A, let's write down what happens at point A. At point A, slope of this slope here, right here, of this isoquant is actually greater than the slope of isocost. This one, the red one. So marginal product of labor divided by marginal product of capital is greater than wage over R here. Okay. And what's wage over R in this example? Or what is the slope of the isocost? So slope of this isocost, slope here is, you can do rise over run. Rise is 90 units. Run is from origin to here 60 units. So slope is negative, right? 90/60. So the slope is in absolute value. We care about absolute values. 3/2. Okay. So at A, right? I know that marginal rate of technical substitution is greater than 3/2. So this is wrong. At A, this holds, while at A, this equation holds. If we rearrange this, if we sort of rearrange this, right, it's going to be, just change the location of these two. Marginal product of labor divided by wage rate, marginal product of capital divided by R. So here it says marginal product of capital to rental rate ratio is greater than, no, it's smaller than the ratio of marginal product of labor to wage rate. C says at A, marginal product of labor greater than marginal product of capital. We don't know this at all. So this is wrong, this is wrong. So none of the above, sorry, that's the correct one. Question number 15, okay? Why wouldn't the firm choose to produce 5,000 with combination B? Okay, combination B, the opposite is happening. So at combination B, all right, what do we have? At combination B, so I'm just going to clear this up to do the B part. Let's see what combination B is at. Okay, so at B, marginal rate of technical substitution, which is this one, right, is in absolute value, is smaller than this budget line, steeper, right? Negative wage over R. Okay, so if we look at the absolute values, right, marginal product of labor divided by marginal product of capital. Again, if you're missing anything, please watch the slides. Wage over R. And wage over R we know is 3/2. Okay. So at B, margin rate of technical substitution is, okay, less than 3/2, correct slope of the budget line. At B, this is true. Let's rearrange these guys. Marginal product of labor, let's just exchange the locations of these. Wage rate greater than. Okay, so this is actually true. Marginal product of capital divided by rental rate. That's true too. At B, I don't know if it holds at all. So D is the correct answer, both A and B. Now question 16 again. What's the lowest possible cost at which 14,000 units can be produced? Same graph, okay? So I'm going to try to clean everything now. Let's clear as much as we can. Open some space. I'm just going to clean it up. Okay, that's enough. Okay, it's asking me, cool, what's the minimum cost of producing 14,000 units? So I'm trying to produce this quantity. Okay, that's actually pretty easy. The least costly way of producing 14,000 units is on this entire ISO cost line. So if I find a cost here, the cost at that point is equal to any point on this line, including the intercept, right? So I have the rental rate information, so I'm going to go to the capital intercept. Why? Because this 180 intercept is actually total cost divided by rental rate. So I'm looking for total cost. I know the rental rate, cost of capital. Total cost is going to be 36. I just multiply these two. $3,600. Let's see. Correct answer is C. Okay, that's right. Question 17. You can find the answer to this question. You're doing it on your own. You can find answer to this question same as question 11. Use those methods. Okay, let's go to question number 18, 1-8. Let's do that. In the following graph, the price of capital is $100 per unit. Okay. Firm decides that total cost must not exceed $3,500. Okay. What's the maximum input it can produce? So we're going to be either here, right? We're going to either produce 500, 1,000, 1,500, I guess. So I'm going to find the cost with R given 100, right? I can use these intercept. Intercept candidate 1, candidate 2, candidate 3. You can use any of these because they're all C over R. And C over R, R is 100 and it's always equal to 50, 35 or 20. Okay? So if we produce 1,500 units, C over 100, okay, let's start with that one, is equal to 500. So here the total cost would be $5,000. That is too much because the company cannot spend more than $3,500. This happens in the non-profit organization. So this is not an option, right? Producing this is not an option. Let's go to the next one. What if quantity is 1,000? Okay, so we are on this isoquant. What's the total cost of producing this? C over R, 3,500. So C, I'm trying to find. I know the cost of capital is R, is $100. And this intercept, which is C over R, is 35. Interesting. Okay, we found it, $3,500. So this company can produce 1,000 units. Maximum quantity is 1,000 units. Let's go to question 21. Okay, this is a fun question. A cow can produce 8,500 pounds of milk. Alright, so this is quantity. 8,500, 8,500 pounds of milk. Okay, you can either feed the cow hay or grain. Okay, so if you can either feed 5,000 pounds of hay and 6,200 pounds of grain. So 5,000 pounds of hay or 6,200 pounds of grain. This is point A. Or alternatively, you can feed this cow 5,600 pounds of hay, but less grain. Okay, 5,400. Point B. So it's asking this over this range, marginal rate of technical substitution. Perfect. Marginal rate of technical substitution is the positive of the slope here. So I'm trying to find the slope in this segment. You're going to rise over this distance over run. Okay. So rises from 5,000 to 5,600. 600 divided by run is 5,400, 5,400 to 6,200. So 6,200 minus 5,400, it's going to be 800. Yes. So it's going to be 0.75 is the marginal rate of technical substitution. And the last question, economies of scope. Economies of scope exist exist if long run total cost of producing X and Y is less than long run total cost of producing X only plus the same unit or Y only. So I am producing, let's say, milk and cream, heavy cream, together in one factory versus milk only and cream only separately. So it's cheaper to produce these two together. So Right now, it says not X and Y goods, but G and V. That's okay, no difference. So, we know that the cost of producing two of them together has to be less than the cost of producing G only or W only. Okay, so B is correct for sure. This A is not correct because it says producing milk and cream together is more costly than milk produced by itself minus the cost of cream. Let's take a look at this one. Okay, this looks like it works. So if long run total cost of producing G and V is less than long run total cost of producing G only and long run total cost of producing W only, if we put this one to the other side, right? LTC GW minus LTC G0 only G less than long run total cost of only W. Okay, so C is also correct. So B and C, E is the correct answer.